Hello everyone, welcome to the OneClass channel. My name is Marlyn. I'm a second year student at the University of Waterloo studying chemical physics and math. Today I'm going to be working through some high school level and college level algebra questions. Be sure to check out the links in the description if you're in need of any extra homework help or would like some one-on-one tutoring. Okay, so for our first question, we're going to be simplifying the x squared plus y squared. This one is quite straightforward if we just remember the fact that when we're converting from Cartesian coordinates to polar coordinates, we have the relation x squared plus y squared is equal to r squared. And so we're just gonna, since these two are equal, and so we're gonna put in this. So root x squared plus y squared is equal to the root of r squared. And this is r squared power 1 over 2. So 2 times 1 over 2 is just x power 1. So it's going to be equal to r as a simplification. So x squared plus y squared is equal to r. Okay, so next up we want to find what quadratic equation is equivalent to what we have here. Okay, so we know that the general form of a quadratic equation is u squared plus bu plus c is equal to 0, right? And so from here we can see clearly that if you just substitute u is equal to x squared minus 1, then it becomes u squared minus 11u plus 24 is equal to 0. We can solve this using the quadratic formula or simple product sum. We want the product to be 24 and the sum to be negative 11. That is going to give us negative 8 and negative 3. Multiply them, 24, add them, negative 11. So our 2 become u minus 8 and u minus 3 is equal to 0. Now, if we just put in u for what it actually is, it becomes x squared minus 1 minus 8 and x squared minus 1 minus 4 is equal to 0. Next up, we're just going to simplify this to become x squared minus 9 multiplied by x squared minus 4 is equal to 0. Again, we want to further write this as a difference of squares, which we can clearly see, to x squared minus 3 squared and x squared minus 2 squared is equal to 0. And you just need to remember the difference of squares rule. And that just simply states that a squared minus b squared is equal to a plus b, a minus b. So in this case, that is going to become x plus 3, x minus 3, x plus 2, x minus 2 is equal to 0. So the quadratic equation that's equivalent to what we have is this, and the solutions of that quadratic equation are going to come from here, and it's going to be x is equal to positive or negative 3, and x is equal to positive or negative 2. So you have 4 solutions. So yeah, this is, the order of this equation is to the power 4. Okay, next up, we'd like to find out which equation can be solved by using the systems of equations given there. And those are all of our options. Okay, and so we know that if we have this system of equations, we'd write it down like this. And so we can deal with this in multiple ways. We can decide to get rid of the y by doing y minus y and then subtracting these two, which is the exact same thing as if we just equate them because this is the same y. And so we can write this again as 3x to the power 5 minus 5x cubed plus 2x squared minus 10x plus 4 is equal to 4x to the power 4 plus 6x cubed minus 11. And so we can already see that as our answer B. Let's see if any of the rest are derived from this. So A is just this half of the equation, and that isn't the full thing, so A is wrong. B we have said is correct. C, we can find out if C is correct by moving all of our variables to one side of the equation. D we know is just this equation, so D is incorrect too. So let's just check out C quickly by moving everything to one side. It's what you'd get if you decided to solve this by subtracting them. And so you would get 3x to the power 5 minus 5x cubed, and then let's move this 6x, so minus 6x cubed, plus 2x squared minus 10x plus 4 minus 11 minus 4x to the power 4 is equal to 0, and then let's write them all down in order. So this becomes minus 11x cubed plus 2x squared minus 10x minus 7 is equal to 0. And so from this we can see that the sign of this is incorrect, the variable here is incorrect, meaning that C is also not a valid answer. So our only valid answer would be B. Okay, we want to find the value of k when one of the roots of the equation x squared plus kx is equal to 6 is 2. So what the roots of the equation are the zeros. So for any of the roots, we'd have ax squared plus bx plus c is going to give us 0. And so or if x is equal to the root. So what this means is we can verify what k is by moving everything to one side. And then you're just going to put x is equal to 2, and this solution should hold. So we get 2 squared plus 2k minus 6 is equal to 0. So 4 minus 6 plus 2k is equal to 0. Negative 2 plus 2k is equal to 0. Let's just add 2 to both sides. These two cancel, and you get 2k is equal to 2. Divide out the 2. And this leads us to the conclusion that k is equal to 1. and that's going to be our final answer. Okay, next up, we want to find the value of the function. What is the value of the inverse function at 7 if the function is 3 over 2x? So if f of x Okay, and so first we need to find this inverse. To find the inverse, we are reflecting in the y equals x line. So what you can imagine this as is if you have let's say we have the function x squared. Let's use one that we know pretty well. And let's use e to the x. Now the inverse of this is going to be ln x. And so we can clearly see that this is just the reflection in the line y is equal to x. So if you just reflect e to the x in this line, it becomes this. And it's practically the same thing as if you decided to switch the orientation in a manner that x becomes the vertical one and y becomes the horizontal one. So what that corresponds to when you're finding it is, let's first label the function y is equal to f of x, which is 3 over 2x. And now what you want to do is label x as y and y as x. You're doing this because you're reflecting it in the line y is equal to x. So that allows for this to happen. And so it becomes x is equal to 3 over 2y. Next up, we want to solve for this y. So 2x is equal to 3y. You multiply both sides by 2. And lastly, let's divide both sides by 3. Let's just write that out over here, actually. And we get y is equal to 2 over 3x. But now, at the end, this y is what our inverse function is. Is equal to f minus 1x. Now we want to evaluate this function at 7. So f minus 1 of 7 is going to be 2 over 3 by 7. And that is going to give us 14 over 3 as our final answer. Okay, next up we're going to be solving for p and I is equal to PRT. Okay, so if you want to solve for p, we want p on one side and everything else on the other side of the equal sign. So let's divide out RT on both sides. And that will cancel here, and we'll get p is equal to I over RT. And that's going to be our final answer. Okay, next up, we would like to expand the logarithmic expression as much as we can. And so we have the expression log a million x. Okay, so first up, we are going to use the property that log to the same base, so let's use base 10, of a times b is equal to log base 10 a plus log base 10 b. So in this case, this is a million times x. And so since they're both to the base 10, if there's no base stated, it's base 10. It becomes log base 10 of a million x becomes log base 10 of a million plus log base 10 of x. And then next up, let's rewrite this in blue. Next up, we're going to be using the logarithmic property, the exponential one, which just states that log base a of b to the power of c is equal to c log base a b. And so we are going to be applying it to this, and we know that a million is equal to 10 to the power of 6. So this means that log 10 is equal to log 10 to the power of 6 and this finally becomes 6 log to the base 10 to the power of 1, because we're just going to leave the 10 on its own, so that's 10 to the power of 1 plus log base 10x. And you know that when the base matches the number in here, then our answer will become the exponential. So log a, that is another property. Base a to the power of c is simply equal to c. And so once we apply that, we get 6 log 10 plus log 10x is simply going to be equal to, c is going to be 1 in this case, so this will all become 1. So it's 6 times 1, which is just 6, plus log 10x. And this is the simplest way to write down our initial problems. Let's just write that final answer down here. And that's going to be our final answer. Okay, next up, we'd like to solve for d in the equation a is equal to negative bcd. So first out, let's divide out that negative 1. And so we get BCD is equal to A. And then let's divide out BC on both sides so that we can isolate that D. And we get D is equal to negative A over BC. And that's going to be our final answer. Okay, next up, we'd like to find out the true solution to the logarithmic equation given to us here. So we have log base 2 6x minus log base 2 root x is equal to 2. And so, again, remember the logarithmic property of log to the same base of m over n is going to give us log a m minus log a n. And so let's just apply that to the left-hand side, and we can get log 2 6x over root x is equal to 2. Next up, we're going to use the property that log a to the b is equal to b. And we're going to apply that to the right-hand side. And so we get log 2 6x divided by x to the power of 1 over 2 is going to be 6x times x to the power of 1 over 2, negative 1 over 2, sorry. And that is going to give us 6x to the power of 1 over 2. So 1 minus 1 over 2, which is just 6x through the 1 over 2. 6x 1 over 2 is equal to log 2 squared. This way we could get 2 as the answer. So this means 6x to the power of 1 over 2 is going to give us that 2 squared, because it's the same logarithm to the same base, which means that the values inside must be the same. And so now we just write this out as 4. Divide out the 6 on both sides. So over 6. And this just becomes 2 over 3. This cancels. So we get root x is equal to 2 over 3. And then next up, we're going to want to square both sides. And we get x is equal to 4 over 9. And that is going to be our final answer. Next up, we want to write the equation in its equivalent exponential form for both of these. So we're just going to need to remember how to go from logarithmic form to exponential. We just need to remember that log base a b is equal to x. In exponential form, just move this a right on over, and it becomes ax is equal to b. So a to the power of x is equal to your value here. And so in our cases here, we have 2 is equal to log 5, 25. So we move the 5 right on over, and it becomes 5 squared is equal to 25. This is true, as we know it. Next up, we have 6 is equal to log 9m. So what that means, you move the 9 right on over, it becomes 9 to the power of 6 is equal to m. And that is our final answer for that. Next up, we would like to solve for v. So I'm going to solve the question given at the top, because there seems to be an error with the question at the bottom. So we have v minus 4 is equal to the root of negative 5 y plus 20. So what this means is we're going to square both sides to get rid of, sorry, no, actually we're solving for b. So this can easily be solved by we just add 4 to both sides. And we get v is equal to the root of negative 5y plus 20 plus 4. In the scenario that the value here was actually v. So let's say we had v minus 4 is equal to the square root of negative 5v plus 20. This can also be solved easily. We just first square both sides. So v minus 4 squared is equal to negative 5v plus 20. Next, we want to expand this out. You just need to remember that x plus a squared is going to give us x plus 2ax plus a squared. So in the scenario that a is equal to negative 4, 2ax is going to give us negative 8x, and a squared is going to give us 16. So let's just write that all out, and we get b squared minus 8x plus 16 is equal to negative b squared minus 8x plus 16 is equal to negative 5b plus 20. I want to bring everything on over to one side. And it becomes v squared minus 8, this is supposed to be v, not x. v plus 5v plus 16 minus 20 is equal to 0. This will give us v squared minus 3v minus 4 is equal to 0. We can use product sum to solve this. So we want the product to be negative 4 and the sum to be negative 3. What two numbers can give us this? And we're going to get negative 1 and 4. So 4 minus 1 is, negative 4 and 1. So negative 4 plus 1 is negative 3, and negative 4 times 1 is negative 4. So that is going to give us v minus 4 and v plus 1 is equal to 0. This means that v is equal to 4 and v is equal to negative 1 are our two answers. Okay, next up, we would like to again express an exponential form. So again, you just need to remember that log a b is equal to x in exponential form. That becomes a to the x is equal to b. So just imagine it coming in and wearing x as a hat. So for our first one, we have log 525 is equal to 2. Apply the same thing. 5 comes and wears 2 as a hat. 5 squared is equal to 25. For our next one, we have log 51 is equal to 0. 5 comes and wears 0 as a hat. This becomes 5, 0 is equal to 1. This is true because of the 0 exponent rule. Okay, this one is quite straightforward. We would like to solve the equation negative x is equal to negative 16. By solving, we mean we want it in the form x is equal to something. We can clearly get that if we just divide out negative 1 on both sides. These negatives cancel and these negatives cancel, so it becomes x is equal to 16. And that's our final answer. Okay, next up, we would like to solve the formula for r. So, a good example of when you need to do this is trying to find your ring size, and you can take the circumference and then figure out the radius. So we have circumference is equal to 2 pi r. We would like to find r. And so what we can do is we can divide out 2 pi on both sides. And you get r is equal to the circumference divided by 2 pi. And that is going to be your final answer. Okay, next up we'd like to find a polynomial of degree 3 with the following zeros. So it's of degree 3, and we have 3 zeros, so they're all to the power of 1. And so for x is equal to 0, this simply means x is quite literally equal to 0. For x is equal to negative 5, that corresponds to x plus 5 is equal to 0. And for x is equal to 3, that corresponds to x minus 3 is equal to 0. And so when we put that all together, we get x times x plus 5 by x minus 3 is equal to 0 as our polynomial. So for the zeros, we know that this equation will be satisfied if x is 0, if x is negative 5, or if x is 3, which means that it is our f of x. And then we just expand that out. So if you x by 5, you get x squared plus 5 by x minus 3 is equal to f of x. Next up, we would like to do x squared by x squared by negative 3, 5 by x, 5 by negative 3. That is x cubed minus 3x squared plus 5x minus 15 is equal to 0. Sorry, is equal to f of x. And this is going to be our final answer. You can leave it in factored form as this, or if you'd like to prove that it is of degree 3, you can expand it out like that. Okay, next up we'd like to interchange between logarithmic form and exponential form. So for this, again, remember how to convert them. Log base AB is equal to x. A sweeps in and where's the x as a hat, so B is equal to A to the power of x. So for our first one, we have log 8 is equal to 1. So it's going to be going, for this example, we're going to be going in both directions. But for this first one specifically, we're going this way. So 8 will come in where 1 is a hat, and it's going to become 8 to the power of 1 is equal to 8. This is true. Next up, log 864 is equal to 2. We're going to be going in the same direction. 8 sweeps in, and where's the 2? 8 squared is equal to 64. This is also true. Next up, we're going to be going in the opposite direction. 8 to the power of 2 over 3 is equal to 4. Now what that means is log 8 of 4 is equal to 2 over 3. That way, if you imagine it coming in and sweeping in, you get 8 to the power of 2 over 3 is equal to 4. Next up, again, we're going in the opposite direction. 8 cubed is equal to 512. This becomes log 8, 512 is equal to 3. So just imagine it would swoop in, 8 cubed, 512. Next up, we have log 8, 1 over 8 is equal to negative 1. Imagine the hat again. 8 to the negative 1 is equal to 1 over 8. 6, we're going in the opposite direction. 8 to the negative 2 is equal to 1 over 64. Then this would just become log 8, 1 over 64 is equal to negative 2. Now if you imagine the hat, it all makes sense. And then they're going to be your final answer. All of these statements should be true, and they are, if you just plug them into your calculator. Okay, next up, we'd like to find the real and complex solutions of the polynomial equation. X to the power of 4 minus 41x squared is equal to negative 400. So first off, let's bring everything to one side. And it becomes x to the power of 4 minus 41x squared plus 400 is equal to 0. Now we're going to use substitution to evaluate this as a quadratic. So if u is equal to x squared, this becomes u squared minus 41x plus 400 is equal to 0. And then we're just going to use the quadratic equation in order to figure out what the answer is. And so that just becomes u is equal to negative b plus or minus the root of b squared minus 4ac over 2a. This is our b value, this is our c value, and our a value is equal to 1. And so if you just plug in all of that, that becomes 41 plus or minus the root of 41 squared minus 4, 1 by 400, all over 2 by 1. And this is going to become 41 plus or minus the root of 1681 minus 1600 over 2. And that's going to become 41 plus or minus the root of 81 over 2. Root 81 is going to be 9. So 41 plus or minus 9 over 2. So for our first value, we're going to get u is equal to 41 plus 9, 50 over 2, 25. Or u is equal to 41 minus 9. That is going to give us 16. We're going to get 32 over 2. Okay, and then now you just want to put back in what we got. So since u is equal to x squared, you get x squared is equal to 25. And this means that x is equal to be positive or minus square root of 25. That is going to be positive or negative 5. Next up, x squared is equal to 16. And this is going to get x is equal to the positive or negative square root of 16. And that is going to give us positive or negative 4. So if you want to write it all down in factored form, we get x plus 5, x minus 5, x plus 4, x minus 4 is equal to 0. And so, yeah, the solutions are right here. Next up, we will be simplifying the fraction 3 over 15. So first we need to see if there are any common factors in both of them. And we can see that 3 is common in both of them. So we're going to want to divide out that 3. And this is going to give us 1 over 5. And that's it. Okay, next up, we want to solve for r. So a is equal to p plus p rt. We can do this in two ways. We can decide to subtract p from both sides. So these two will cancel. And we get a minus p is equal to p rt. Next up, you divide out the p and t. And we get r is equal to a minus p over pt. The second version is we can decide to factor out the p. So we get 1 plus rt and then divide out p. So a over p is equal to 1 plus rt. Subtract the 1. So a over p minus 1 is equal to rt, and then divide out the rt. Sorry, divide out the t. And we get a over p minus 1 over t, which is equivalent to exactly what we got before if we multiply this entire thing by p, a minus p over pt. And that's going to be our final answer. We can view this as p over p is 1. Right. Next up, we would like to find the value of the expression log base 4 squared is equal to what? So we need to remember the logarithmic property of log a e to the power of b is just going to be equal to b. So in this case, we see the base matches the value here. This means that log base 4 squared is going to be equal to 2. Okay, next up, we're going to want to solve for L in this. So V is equal to length by width by height. And we can solve by L if we divide out the width and the height on both sides. These two will cancel and we'll get the length is equal to the volume over the width times the height. And that's going to be our final answer. Okay, next up, we'd like to simplify the logarithmic expression log to the base 2 of 128. So again, we're going to be using the rule I wrote down earlier, which is log to the base of a to the power of b is equal to b. This is true because of this logarithmic property, which just states that log to the base of a of b to the power of c is just going to be c times log base a b. And we know that log base a is equal to 1. So this should become b log a, and that is going to be equal to b. So what they're basically asking us to do if you want to get a number as an answer is express 128 in the form of 2 to the power of something. And you want to find out what that something is. And so we know that 128 is 2 to the power of 7. And you can just figure that out by doing the numbers or using a calculator. But that means that log to the base 2, 128 is equal to log to the base 2, 2 to the power of 7. And that's going to give us 7. That is going to give us 7 log to the base of 2, 2, and this is going to give us 1. So that is going to be 7. And that's our final answer. Okay, and those are all of the questions I have for you today. I hope you enjoyed today's Q&A. If you'd like to be aware of any more posts, be sure to hit the subscribe button and the bell next to it so they can notify you when we do post. If you'd like to post questions of your own, be sure to check out the links in the description for OneClass links to homework help and one-on-one tutoring. This is Marlyn from OneClass, and I hope to be seeing you next time.